Hi everyone. In this video, we will talk about how we can use biochar to produce low-cost clean drinking water. So we will discuss about the contaminants removal and their interaction mechanism with the biochar. The global demand for safe drinking water is becoming increasingly important. The growing world population and anthropogenic activities cause the rapid contamination of the water, presence of various contaminants. According to World Health Organization, around 2.1 billion of people lacks clean water, and out of which 159 million of people are directly consuming drinking water from the surface water, which are highly contaminated. The most challenging issue associated with surface water is the occurrence of organic, inorganic, and microbial pollutants. While exposure to these toxic contaminants can cause severe health issues, such as studies shows potential cancer risks with the presence of carcinogenic materials in drinking water. In some other studies, arsenic and skeletal issues in some of the areas has been found due to the presence of fluoride contaminated drinking water. So these contaminants must be removed from the surface water before it has to be drank by the human. So biochar based water treatment systems can provide a cost-effective, eco-friendly, and sustainable treatment units to remove all of these contaminants from the surface water and providing a very clean water. For example, in organic contaminant removal, various organic contaminants such as pesticides, herbicides, fertilizers, liming, acidifying agents, and pharmaceuticals are in the surface water. So biochar showed efficient removal performance of various contaminants like switch, grass biochar, waste biochar, and these biochar showed highly removal performance for various organic contaminants from biochar. So the possible removal mechanism of organic contaminants using biochar includes the chemical and physical interactions between the biochar and the adsorbate, the presence of oxygen surface functional groups on the surface of biochar such as hydroxyl groups and the carboxylic groups play a dominant role interacting with the organic contaminants. The formation of hydrogen bonds between the polar functional groups of biochar and organic contaminants between the polar surface groups of the biochar and can remove the organic contaminants. Similarly, the carboxylic acid and carboxylate and phenolic groups present on the surface of the biochar act as either a hydrogen donor or hydrogen acceptor and can interact with the organic pollutant by means of electrostatic interactions. So we have some other interactions involved, like we have hydrophobic interactions. The hydrophobic group of the organic contaminant may interact with the graphite structure of the biochar and form hydrophobic interaction. So as we see that biochar is highly porous in nature, so we can also find a pore filling behavior for the removal of various organic contaminants. Biochar is negatively charged due to the presence of different surface functional groups. Therefore, the organic contaminants may be interacted onto the surface of the biochar by electrostatic interactions. So these are the main interactions like hydrogen bonding, carboxylic and carboxylate interactions, electrostatic interaction, pi and hydrogen interaction, pore filling behaviors are the main removal mechanism for the removal of organic contaminants using biochar. So inorganic contaminants such as metal and excess nutrients are mainly present on surface water. So these contaminants can also be removed using biochar, and biochar showed high degree of removal up to 100% of these contaminants, such as magnetic biochar showed high adsorption of arsenic from water and wastewater. Aluminum oxide coated biochar completely removed fluoride ions from water. Iron modified biochar showed almost 99% of phosphorus removal efficiency from water. So, despite organic contaminants, biochar can also remove heavy metals and nutrients from the surface water. So, the possible mechanism of the inorganic contaminants removal using biochar involves hydrogen bonding, ion exchange, metal complexation, electrostatic interaction, and pore filling. So, the abundance of negatively and positively charged sites on the surface of the biochar enables the interaction with the cations and anions from water. The carboxylic groups, right, and the hydroxyl groups on the surface of the biochar involved the interaction with metalloids by means of three interactions like the formation of complexes, right, electrostatic interactions, and anion exchange mechanism. So these are the main mechanisms involved the removal of various cations and anions contaminants from water using biochar. So microorganisms like E. coli or Enterococcus and other pathogens are also present in high concentration in surface water. Now, many of the studied biochar showed up to greater than 90% of the removal of these microbial contaminants from surface water. For example, forestry wood waste biochar removed E. coli by 96.6%. In another study, steam activated softwood biochar showed almost 100% removal of E. coli from water. And in most of the studies, biofilters produced from the biochar remove both E. coli and enterococcus from natural stormwater. So as most of the microbial contaminants are alive, so the interaction of biochar and the microbial contaminant depends on the properties of the biochar and contaminant properties. So due to the porous nature of and high surface area of the biochar, it can provide more surface active sites for the removal of microorganisms through different mechanisms. In microbial contaminant, the presence of lipid-containing compounds such as phospholipids and lipolipids on the membrane of the bacteria make these organisms hydrophobic. So they interacted with the surface of the biochar by means of hydrophobic attachments. In another study, similarly, phosphate groups are also present on a bacteria falls, so which makes them negatively charged. So they can also interact with the surface of the biochar by means of electrostatic deposition. Thank you so much for listening.